Hello. Hi. Um, I'm just going to show you um, a little video of the ball turning attachment that I made for the TAG, and it's not my design. It came from, I think it was the model workshop, I think. Anyway, um, what happened was that I bought this double-faced dial test indicator, and it came with this adapter that screws on the top there, and it's okay. It works okay, except that when I have it in my my holder, that I sliding adjustable holder that I have on the mill, it only swivels, as you can see, only swivels in one direction, or moves backwards and forwards. It doesn't swivel, and sometimes when I'm trying to find a hole, I need to move the dial indicator sideways, and it doesn't really work very well. So what I decided to do was to purchase one of these swivel holders. They work very well, but I didn't ask the seller what the thread was. I assumed that the thread would be like a standard thread, and it's not. This is probably a Starrett unit. It only cost me $15 plus shipping, about $25. And I thought, well, rather than make one, I'll buy one. But this is no good because it's a different size thread. So I've decided to make my own one. And what I did was, I've already made the ball. This is 304 stainless steel, and I made the ball with the ball tool, ball turning tool I have. So I thought, while I've got it set up, I'll just give you a little demonstration of how it works. I mean, there's nothing really to it. It's just a ball turning tool, but it's a slightly different design, and it's this block here turns around the bolt hole, and on this side there's a micrometer adjustment for putting on a cup. And so I just thought I'd give you a demonstration on a piece of quarter stainless steel. The tool bit that I purchased solely for this job, or for this tool, is it's called Crowbolt, and it's a better material than HSS, but it's not as good as carbide. So you can increase the speed with this material, but not as much as you would do if you had carbide tooltips. So anyway, I'm going to start the machine up and move that out the way, and I'll just give you a little demonstration. Now on here, this is just a Heath Robinson piece. I should have set this turning tool further over on the table, because you're supposed to put stops on either side so that when you come round, the edge of this tool butts up against a stop. But I couldn't do that because I'm too far this way, so I just stuck this in there, and this makes contact with the nut and keeps it in position. So I've already started turning. Now this is an old piece of stainless steel. It's got a groove in the middle, so I'm just going to make any size ball, but this will give you an idea of how this tool works, or how well it works. It does work very well. So you just undo the block, and you put on a cut, and you just nip it up, and there you go. I've got the tool running at 1100 RPM. That's the first cut. Now you'll notice that you'll probably notice that it's not cutting on the front edge. It won't do that until I get down to a certain size. But this doing it, feeding it in like this, gives you a nice neck, which is what I want, because the unit here, it has to drop down into slots, you see. So the neck needs to be at least a certain size for clearance. So I'll just carry on now and do a quick It's almost touching the front edge now. Not quite. I have to make sure that the carriage is locked up. It's pretty tough stuff. It's machinable, but it is quite tough. But I find that stainless steel, as long as your tool bit is properly sharpened, just touching, you do get a very nice finish. You know, I'm cutting on the front edge now. And I'm cutting dry as well, so I've already done a demonstration previous, a while back, when I first built this tool, but I just thought I would, while I've got it set up, I'll do a little video. thin the neck down afterwards if I have to. Make sure that I had it set for a 1/4 inch ball, so seeing as I'm making the ball smaller because of that piece that was already machined on the part, it means I'm going to maybe get a little bit of a pip on the very front of the ball, which in this case it doesn't matter because this is just a demonstration. To make sure that the cross slide is clear of any cuttings, so it doesn't get wedged underneath. Almost there. I know the camera is not in a very good position. Go. So a little bit of a pip on there at the very tip. That's because the ball is smaller than it was meant to be, and the radius was set at a quarter inch diameter. So, but as you can see, it's not a bad ball, and that's pretty tough material. So there you go, that's the tool, and just I'll take the camera down and we'll do a little, let's see, where are we? There we are. So that's what the tool looks like, and it swivels on thrust bearings. I've got some thrust bearings on the centre spigot underneath there. The bushing is bronze, and underneath I have a plastic sheet. It comes from the old X-ray machines that where I used to work. They were the black thin plastic that they used to slide in the cassette before they put it in the machine to take the X-ray. I had a little sheet of it, and that's what I've got underneath. So it's hard, but at the same time it's soft, and it helps not to damage the cross slide table. But you have to make sure that when you're swinging it, there's no cuttings on there, just in case they get in underneath and then you start scoring the table. So if I can keep the table as clean as possible during its duration, then that's an advantage. Okay, and here's the old setup. This is off of a press tool. This was a stripper plate with a plunger in there, sprung-loaded flat plunger that you pushed the material in, you blanked, and then you pushed it again and it came up against there, and you released the pin when you moved it forward. So that's what that is. It's a piece of ground, or probably gauge plate, or what do you call it over here? In England you call it gauge plate, but here it's called ground stock, is it? Yeah, ground stock. So that's what that is. I use them as parallels, and they're all ground, and the edges are ground and surface ground. So there you go. That's what I've been up to today. Thank you.